Good morning, everybody. Long time no see. I haven't been on a tech talk for about, well, weeks actually. I don't know how long exactly, but probably about 6 or 7 weeks. But yeah, I mean alone. I've done collaborative, but welcome to it. I thought we would just revisit something that, well, we haven't really looked at it particularly in particularly this subject. We've covered it in a lot of, it's been mentioned in a lot of other talks as well. We always mention shut-off valves and stop taps and that. But it occurred to me that, a lot of the inspections and audits that we do, we often come across just a misunderstanding of what the actual requirements for the positioning of shut-off valves are within a property or within an installation. So I'm just going to, there's a section in SANS 10252-1 which talks about shut-off valves and what to do with shut-off valves, where they're required, etc. And I just took it from there and I said, let's go and have a look at exactly where these shut-off valves are required, and we can have a discussion about that. So this is literally a direct translation from there, but it covers pretty much all the things one needs to know about where to put shut-off valves and so on. First of all, what is an isolating valve? Why would we want to install an isolating valve? What's the purpose of an isolating valve? Well, there's lots of purposes, or I suppose we could point to a lot of things, but for me, there's three main things. First one is to shut off the water supply in an emergency. If you have an emergency burst pipe, you need some place for a lay person, a person that does not know about plumbing, to be able to go to and understand how to stop the flow of water in an emergency. So that's number one. Number two is isolate particular portions of a water installation. What do we mean by that? Well, depending on the installation, and remember, we're talking about broad strokes here. It could be any installation. It could be a geyser, as we look at that as an installation. It could be an entire complex, it could be whatever. So you need to be able to isolate certain portions of any installation, whether that be a section of pipe, whether that be a valve, whether that be a geyser or whatever. So that's the second, in my estimation, sort of important function or purpose of an isolating valve. And the third is to allow for the ease of maintenance and repair and replacement of components. So we need to place isolating valves in positions where it will allow us to easily maintain or repair or replace stuff that needs to get repaired or replaced at some point in time. So the components, the bits and pieces of an installation, and that can include like a pressure control valve or a pressure, well, I said a PRV, but we all understand a PRV to, it's probably incorrect. I should have said PCV, because a pressure control valve is what I meant there. But it could also include pumps. We need to maintain and repair and sometimes replace pumps, non-return valves, filters. If you need to service this non-return valve, or if it's a spring-loaded non-return valve, you need to service it from time to time. If it's a filter, you'd need to service it from time to time and clean it out. You cannot be expected to have to drain the entire installation just to clean out a filter, for example. Okay, so that's an example. Another example would be a solar system, where you would want to maintain or repair a particular part of that system, and you don't want to have to drain the entire geyser to replace the panel, so you need shut-off valves there, etc., etc., etc. Okay, so that's the three main sort of broad strokes purposes of isolating valves as I see it. Types of isolating valves, I'm not going to teach you anything new here, and I'm not going to go into every single type, just the sort of the basic stuff that we use on a day-to-day basis in a domestic installation sort of scenario. Lever ball valve, we're all familiar with all of these. The lever ball valve is used very, very often, and we'll talk about that just now with the standard say, about that. Gate valve, we're all familiar with. What is the, just as a matter of interest, a fundamental difference between these two? And it's obviously the design, but in the way that they close, and that's a consideration that we need to always bear in mind where we're putting in what kind of valve. So this valve you can shut off suddenly, and you can cause tremendous hydraulic shock and water hammering the line, whereas this guy, you can't really do that. And the same applies for these next two as well. Butterfly valve, obviously that's for larger installations, which is not common in domestic, but it's a lot of complex supplies will have butterfly valves in them. And then a stopcock that can be shut off quickly. This can't. A stopcock can't be shut off quickly. Same applies to angle valves. So between a stopcock, gate valve, lever ball valve, and angle valve, that's pretty much the scope of the shutoffs or isolators that we're going to use in a domestic situation. So within that, there's obviously quite a lot of variations and variants and so on and so forth. Before I carry on to placement of these valves, I suppose it's fitting to remind us all that whatever valves we use, it's got to be SABS approved or JASWIC listed or SA watermark listed. So don't use anything that is not an approved type material. Okay, so let's move on to placement of isolating valves, and this is where I've pretty much taken it directly from the standards and what the standards tell us about isolating valves. And this is where misunderstandings sometimes occur. Often we come across different interpretations of these standards, and so hopefully this will clear it up. So the section is 6.1.3, and as I said, this is in SANS 10252/1. So it says isolating valves, unless otherwise required, and we'll get to this in a minute because it says unless otherwise required or provided that 6132 does not apply, and we'll get to 6132 what it says, and I'll explain what that means because it refers to it right in the beginning. So it says unless 6132 does not apply, a specific, or not unless, I beg you, or provided that 6132 does not apply, a specific isolating valve shall be provided. Then it starts. A, in the case of any water meter installed outside the boundary of the premises. So if that water meter is installed outside the boundary of this premises, then it shall be in the service pipe at a point not exceeding 1.5 meters inside the boundary of the site. So in other words, that distance over there is a maximum of 1.5 meters in the case where you've got a water meter installed on the outside of the boundary. B, in the case of any water meter installed inside the boundary of the site, so if the water meter was installed somewhere inside the site, now we're talking about any site, eh? So this is a single dwelling. A site would also be the earth of a multi-dwelling complex. So you could have a complex with 20 units, and within the boundary of that site, the water meter is installed in a manhole which is accessible to within the site. So it might not be outside. In that case, you shall have an isolating valve at a suitable point on the consumer's side of the water meter. Now, in both of these cases, it says to us clearly that there needs to be an additional shutoff valve after the water meter. A lot of installations I go to, there is no shutoff valve after the water meter. The main shutoff, or the water meter's shutoff on the council side, is deemed to be the main shutoff. And when you inquire about this, the owner says, no, I just use that. Okay, have you got a personal or an isolating valve on the upstreams, on the downstream side? No, I haven't. Okay, there's a problem. So it's clear that wherever you have a water meter, you must have one after the water meter. So C, where a pipe enters any building or any portion of a building in separate occupation. So what does that mean? So there's my isolating valve after the meter, right, as per the thing. But here's two portions of this building which are in separate occupation. This is one home, it's a granny flat. We're not talking about two separate units because that, well, I mean, like flat A and flat 1 and flat 2 in a complex, that's obvious. But what is less obvious is a one home situation with a, let's say, a granny flat. Each branch of that pipe that supplies that granny, well, that supplies each portion of this home with water needs a shut-off valve, separate shut-off valve to the main one. You cannot just have this main one on the owner's side of the meter and say, oh, well, that's our main shut-off. No, it's clear. It says where any pipe enters a building or any portion of a building in separate occupation. So it's very clear that you need this additional shut-off valve there. And this, again, is often something that we don't see. In fact, if you were to remove this this separate occupation portion here, this granny flat portion, let's just pretend that this branch wasn't here. Let's pretend that this was a straight pipe from the meter through the isolating valve with after the meter, which is a requirement which is linked to the meter. And then when that pipe enters the building, what does it say here? It says where a pipe enters any building. Okay, that's a statement. And then it goes on to say, or any portion of a building in separate occupation, which means this. But if we were to get rid of this granny flat and just say this is a normal home, I have a water meter, I have a shut-off valve after the water meter, and I have a supply entering my home. At that point, I need another shut-off valve, regardless of this guy over here. So that's an important thing to realize, because again, often it is deemed unnecessary to have this, or this is nicely forgotten about because I've got a shut-off valve after the meter, so I'm cool. No, it says where it enters any building. So there needs to be a shut-off valve there. And if it's a separate occupation, you need an additional one there. Ruben, if there's any questions, you're more than welcome to stop me, because I know yeah, and you know my story. I don't mind being interrupted. Okay, D, on any branch pipe that serves a flushing system and next to the system. In other words, wherever, and we know this is never really not adhered to. It's always, we always put shut-off valves before flushing systems. So it says where any flushing system must have a shut-off valve, and it must be next to that system. In other words, it must be just for that system and next to the system, which we use. And these days we use those angle valves. It's much simpler. E, on any branch pipe that serves an automatic flush valve or a flushing valve, unless such flush valves incorporate their own isolating valves. Something like this will incorporate an isolating valve, but it's always tricky to get to. And the manufacturers would probably be very happy that you were to put if you were to put an additional isolating valve on the supply line to this thing. So yes, the standards do say unless it incorporates their own isolating valve, which this does. So essentially it's not something which would be non-compliant, but it's certainly preferable. But if, of course, if the flush valve does not contain its own isolating valve, then of course that needs to be put in. On each side of and next to any backflow preventer, okay, be that a DZR, listen to me, a RPZ valve, or any other type of vacuum breaker, or I get my mind mixed up, backflow preventer, I beg your pardon, or a combination of a backflow preventer and pressure reducing valve, such as the case may be. So on both sides of upstream and downstream of any backflow preventer, that includes an RPZ like this, or a simple spring-loaded non-return valve like this, upstream and downstream of backflow preventer. Then pressure reducing valves. If the pressure reducing valve has an inlet diameter exceeding 25 millimeters, so if it's more than 1 inch, in other words, starting from size 32 mil, 1 1/4 inch, okay, from 1 1/4 upwards, it must be on each side of and next to any pressure reducing valve starting from 1 1/4 inches. Now you say to me, hey, hang on a second, you said we can't put an isolating valve downstream of a PRV because, okay, hang on a sec. So let's talk about it. This is a pressure reducing valve. It's not a pressure relief valve. This is just a reduction of pressure, and the relief component is separate from this. So that is what they are saying here. But if it's less than 25 millimeters or equal to or less than 25 meters, not exceeding 25 mil, in other words, 1/2 inch, 3/4 inch, 1 inch, on the upstream side of any pressure reducing valve of nominal inlet. So only on the upstream side of a pressure reducing valve do we need a separate isolating valve. Usually 3/4 inch pressure reducing valve has got a pressure relief component built into it as well, and that's why we shouldn't, well, we can separate the two. It depends on the design of the situation, and of course we can install additional relief valves if we want to, but for purposes of what the standards require, anything from starting from 1 1/4 inch must have both sides, and anything less than or anything 1 inch and down only needs one side, in other words the upstream side, to have an isolating valve. In such positions that, should it become necessary to drain any pipe, the total length of the pipe that has to be drained between isolating valves does not exceed 30 meters. So that's quite simple. If you have a very long water supply to a particular place, so every 30 meters you need a shutoff valve. I don't think that's going to be very common, but anyway, that's what it says in point I. Then J, it says in the case of any storage tank, on the inlet pipe next to and upstream of the valve controlling the supply to the tank, which means the float valve. This is the valve controlling the supply to the tank. So this is upstream of and next to. Okay, in other words, it must be right there. It can't be 6 meters away. It's next to it and it's upstream of. And then on the outlet of the outlet pipe from the storage tank and next to the tank that supplies water to the water installation. Remember that this is a storage tank. This is a cold water storage tank. It's not we're not talking about a geyser. So it requires a shutoff on the inlet as well as the outlet. Note, any isolating valve used to shut off the supply to a storage tank should be of a type that cannot be suddenly closed. For example, it should be a gate valve rather than a butterfly valve, or a stopcock rather than a lever ball valve. So we don't want a situation where, because storage tanks often are quite large tanks and the diameters of pipes that supply them are quite large, and you don't want sort of severe water hammer occurring when you shut that thing off by mistake too quickly, because sometimes it's quite large diameter pipes. Right, we said right at the beginning, it said provided that 6132 is not a situation. So what is 6132? Okay, so it says, notwithstanding the provisions of 6131, an isolating valve shall not be provided between any pressure reducing valve and a water heater if such a pressure reducing valve incorporates an expansion relief device or vacuum relief device intended to protect such water heater. We all know that normal pressurized geysers do in fact have usually a pressure control valve which incorporates a relief component. So we cannot have a situation where we've installed a shutoff valve or any kind of restriction between the relief and the geyser. Okay, so that is sometimes what we come across, and that's not so lekker. 6133, any isolating valve in hot water installations shall be of the full bore type in order to limit the effects of scale formation within the valve. So apart from a couple of other nasties here, this is a hot water outlet pipe, and these are two valves used, which are normal stopcocks used to control the flow of the hot water. It's within a hot water installation, and these should have been, okay, and I say, let's not talk about the other nasties, but these can't be there. They need to, if you're going to put them somewhere, they need to be lever ball valves. Okay, so that's what the standards say. I don't know if there are any questions there, Ruben. I know most of this stuff is what we know already, but certainly regarding the placement of valves within a boundary of a site and within a new build, I think it's often overlooked. Thank you very much for the attendance. Fantastic audience again. Huge numbers. So really, really nice. Thank you.